So my name is Dominic. I was given the opportunity to open this day, so I'll try to make this presentation as exciting as possible. So if I get boring, just tell me and I'll try to do a backflip or something. So what I'll present to you today is Iota, like who we are, where we come from, and kind of the use cases that we're working on, so that we have this transition to the panel afterwards. So kind of the backstory of Iota. So the founding team of Iota are really pioneers of this blockchain space. So back in 2013, we invented the first proof-of-stake blockchain. And because we really have this deep technological knowledge, we kind of realized, hey, every blockchain that is out there today is not able to run in this Internet of Things environment. And so what we did in 2015, we came up with a completely new architecture to solve these issues of machine-to-machine transactions and of micropayments. So the thing about Iota is that it's no longer based on a blockchain. So we say that we go beyond blockchain because the sequential chain is really limiting. So we always joke that Iota is a blockchain without the blocks and without the chain. So if we discuss semantics, it's no longer blockchain, right? So the way that Iota looks like is kind of like this. So instead of having the sequential chain, we have this directed acyclic graph. So you could kind of call it a multi-dimensional blockchain. Because instead of the sequential chain, we have this kind of multi-threaded mesh. So what you see here is there a pointer? No, I don't think so. But so what you see here is these kind of blocks. So each block here is one transaction. So one transaction references two past transactions in the history. And through this referencing, you kind of get an attestation. So one transaction says directly, hey, these two transactions are valid. And because of that, we are able to achieve consensus in a much more interesting way than any blockchain that is out there today. So Iota's main features are two components. So for one, we have this data security. So in Iota, you can issue a transaction where you're where you want to secure data. So this concept of data integrity and making data tamper-proof, like we've seen in Bitcoin, for example, proof of existence. It's similar in Iota, but the beauty of Iota is that there are no longer any transaction fees. Secondly, what we really focus on is machine-to-machine payments. Like how can, for example, this car over there pay a parking station or a toll station? And with Iota, we are able to really achieve this beautifully. So the big question is like why am I on stage and why is Iota awesome? So first of all, we have no transaction fees. In Iota, there are no longer any miners, but it's a very decentralized network where each network participant participates directly in the consensus and in the security of the system. Because each network participant contributes towards the system, there are no longer any transaction fees. And because of that, in Iota, for the first time in human history, you're able to transact 1 cent and the other party is able to receive 1 cent. And that's incredibly interesting for all of the companies that are out there today, because at the end of the day, they have a business model that runs on top of a blockchain. And if they have an uncertainty of the transaction fees or how much money they're going to get, they have an uncertainty if their business model is actually profitable or not. With Iota, we have this determinism. You know, if you send 1 cent, you receive 1 cent. Oops. Secondly, we can scale really, really well. The beauty of Iota is that it scales horizontally. What this means is that with the number of nodes, with the number of network participants, the scalability and the transaction finality, like when a transaction is ultimately confirmed, increases or decreases. And as such, in Iota, we are able to scale much faster and we are able to achieve transaction finality and transaction confirmation times much faster than any blockchain. And obviously, we've been in production. We've used Iota since 2016, where we've launched a Genesis transaction. And so far, we've transacted more than $4 billion with Iota. So this is obviously just the beginning. And the first production-ready applications on top of Iota run by large conglomerates are going live early next year. So who are we? Like I said before, we are really technologists, so we invented proof of stake, we invented the first decentralized asset exchange, and so we have this deep technological background knowledge of software and hardware when it comes to blockchains and distributed ledgers. And because of that, what we did is we set up the first non-profit foundation in Germany to really focus on further developing this knowledge of distributed ledgers and to also standardize it. because standardization is really crucial when it comes to the adoption of any distributed ledger. And what we're doing with the Iota Foundation in Germany is we're bringing together all of these large corporates to work together with us to further drive the adoption and to further drive this co-creation and co-learning. Because at the end of the day, every company that is out there today is doing a proof of concept. But we have to share this kind of knowledge, the do's and don'ts that we get out of these proof of concepts. And the Iota Foundation is the entity to really drive this. So this is some of the team members. So right now we're more than 30 people. What we are is mostly research and developers. And right now we have offices in Berlin and in Oslo, and we actually really want to set up an office in Shanghai. And we're setting up another office in Chicago together with Bosch Connectory. And we also have some really good advisors on board, like for example Richard Soley from the Industrial Internet Consortium, or Oliver Bussmann, who is the ex-CIO of SAP and of UBS. So our vision, like I said before, is really that one machine can pay another machine. The thing about machine-to-machine payments is that it's not going to happen via cloud, but instead every machine needs to have the ability to have a wallet. And once a machine has a wallet, it can earn money or it can pay for services. And through that you kind of get this machine economy where one machine with access resources, with access capabilities, can sell this service, can sell this resource to another machine that needs it. So we always call this towards smart decentralization, because everything that we have today is based on the cloud. And the cloud as a central decision maker, the cloud as a payment processor, is not going to work in the future, because the cloud has network congestions, it has scalability issues, but instead of having the cloud, we need to have this local environment where one machine transacts with another machine, and through that you get this kind of bottom-up intelligence. Like for example, these aunts, where the aunts are starting to coordinate with each other directly. And we always call this the next sharing economy, because like I said, one machine with access resources can sell this resource to another machine that really needs it. And another thing is, this ownership is outdated. So why should I own an expensive drilling machine if I just want to drill a hole in a wall? Instead of buying the machine, I want to be able to lease it. I want to be able to rent it on demand and only use it per resource unit, per entity that they utilize. And the really interesting thing about this machine economy is that the machine is no longer bound to its hardware. What this means is that even a tiny microcontroller is able to have the same capacity as a supercomputer. And it is incredibly fascinating, because now we have this kind of platform where we can build new applications on top, and we no longer need to think about the hardware limitations, but we can just say like, hey, this machine has a wallet, and with this wallet it's able to buy whatever it wants. So let's discuss some use cases. So one of the first use cases that we work on together with Bosch is together with the Bosch XDK. So this is a tiny microcontroller. It's a 32-bit Cortex. And we have Iota running on this microcontroller, and what we want to showcase is how this microcontroller can, for one, securely transmit data to the cloud, because we have this data integrity. And secondly, we want to showcase how this microcontroller can actually buy access to a certain resource from the cloud, like for example, machine learning on demand, or any other resource that the cloud makes available. Another use case that we work on together with Energy and with Volkswagen is this Car Pass project. So basically what we're doing is we're integrating Iota into the car, and we have this secure audit trail, like what is happening at each point in time inside the car. And the beauty of this system is that now you have a secure audit trail that not only Volkswagen can share with their partners, but that the customer can share with the mechanic and with other parties. Oh, by the way, what's very interesting about this use case is that in the first time we've utilized a permissioned blockchain with ChainDB together with a permissionless distributed ledger like Iota. And through that you kind of get this second layer of security. And I think that is one of the first really interesting use cases where we're pushing really the thinking, because at the end of the day, most of the use cases that we have today are either based on a permissionless blockchain or on a permission system. And with this use case, we're combining the two to really get a new application structure. Another use case that we work on together with Energy and Share and Charge is EV charging. So we want to showcase how a car from Oslo can drive to Rome purely based on Iota and blockchain-based EV charging stations. So what we're doing here is we're simulating an entire network of cars that are driving from Oslo to Rome. And our intention is really to also compare Iota with Ethereum in this use case, to showcase, hey, like you don't need smart contracts when it comes to EV charging. So the way that this proof of concept is structured is that the EV charging station has a wallet, the car has a wallet, and they're able to transact directly with each other. And with this use case, what we're doing is we're kind of simulating these interactions. Another use case that we're working on is for Industry 4.0. So obviously the thing about Industry 4.0 is that as our machines get more and more connected, the attack vectors become increasingly vast. And at the end of the day, you want to have your factory secured, because if a hacker is able to intrude your factory, they can take your IP, and they can even blow up stuff. And like, there's actually a recent example where it happened in northern Germany, where a factory blew up because of a hacker. And what we're doing with this use case is we're actually showcasing how we can have the secure audit trail of the machines so that the third-party auditor and the internal people can know what happened at each point in time when the machine did the process. More interesting than that is that we can actually issue commands to the machine. We can say, hey machine, do this and that based on a distributed ledger. And through that you get this data integrity and this security, which is really crucial for Industry 4.0 to actually take off. Another interesting use case, also with some large OEMs, is over-the-air updates. So what we want to showcase is how can we achieve end-to-end verifiability when it comes to pushing updates to our machines. So what we're doing here is the car has an Iota node, the central issuer has an Iota node, and what they're basically doing is they're hashing the software update, sending the software update to the car, and the car is able to verify in real time the software update. And so through that, the car knows, hey, like this software update was issued by the OEM. And more interesting than that is that the OEM can validate. They have this audit trail inside the car so that they know which software was flashed on the car. And that's incredibly interesting for over-the-air updates to actually work, because they're a huge issue. And like issuing an over-the-air update that is faulty or malicious to millions of cars, that's a huge threat. And we're trying to solve that problem with Iota. Another use case that is probably even more interesting is a data marketplace. So together with more than 24 of the largest conglomerates in the world, we're right now setting up a data marketplace. And what we're doing there is we want to showcase how our companies in the future are able to buy and sell data on demand. So you're not going to have a subscription service, but you're going to pay per data packet that you're going to buy from another company, or even from a private person that has just set up a weather station. And like I said before, everything has a business model behind that. And with this showcase, with this demonstration, we really want to further the thinking when it comes to micropayment business models. Like how can you really make money with those micropayments? And the beauty of the system is that I, as a consumer, I obviously own my data. But I don't want to just be a consumer, I want to be a prosumer. And with this data marketplace, you can set up a weather station and you can really start selling the data. So time for a demo. So if you guys want to go to this website, you can actually try out our Industry 4.0 audit trail showcase. So basically what we're doing here is we have the secure audit trail. We are simulating how you issue a command to the machine. And everything here, I hope you guys don't crash the website. Don't blame me if it doesn't work. So what we're simulating here is how you're issuing a command to the machine. And you're obviously issuing the command in the browser itself. So the beauty of the system is now we have the data authenticity, so we know that you issued the command, and we have the data integrity, because nobody can tamper with the data. And as such, the machine is able to validate everything and then execute the command. And like we see here, we have the secure audit trail. So you know at each point in time which command was issued, which command did the machine execute, and as such you can be certain what happened in real time and what actually happened. So yeah, that was my presentation. Are there any questions? Do we do Q&As? Yes, so obviously you can't compare Iota consensus to blockchain consensus because like of apples versus oranges. Oh, I'll repeat the question. So the question is, how do we achieve consensus in the system? And the thing about consensus in a blockchain is that it's always probabilistic. Because like in blockchain, you have this heuristic that says after 6 blocks in Bitcoin, you can be certain that your transaction cannot be reversed. In Iota, we actually have a similar heuristic that says after a certain time, you can actually be certain that your transaction is valid. Let me just go back real quick. Okay. So like I mentioned, we don't have any miners. Because the thing about miners is that they're kind of the gatekeepers of the blockchain. And in Iota, every time you issue a transaction, you validate transactions. And through that validation, you're directly confirming these. So let's say that you issued this transaction. So what you're doing is you're directly attesting that these 2 transactions are valid, but you're also attesting that this entire subchain is valid. And through that, you can kind of get this confirmation stream. So then the beauty of Iota is that as more and more transactions are being made, the security of a single transaction also increases up to a certain point where it can no longer be reversed. Like in blockchain, we also have this heuristic that after a certain period of time, after a certain number of transactions, you can be certain that the transaction cannot be reversed. And through that, you get the security in the system. I don't want to talk about transaction finality because that's kind of complicated and will probably confuse a few people. But I can do it if you want. Yeah.
Okay, great.
Yes, thank you. So you have mathematically, you can prove that in terms of transaction finality or things away.
Exactly. So the main difference is that blockchain has a very rigorous consensus system. And in Iota, we kind of take this loose approach to our advantage, because the thing is, if you have a rigorous consensus approach, you directly limit the scalability of the system. Because now you're limited to how fast can this miners actually validate their transactions and propagate them to the entire network. In Iota, we're no longer limited to the consensus algorithm because we're kind of asynchronous, right? Network participants confirm transactions simultaneously. And as such, we are able to achieve the transaction finality much, much faster than any blockchain.